Okay, so we're on the 7-note away perfect fifth here. This 5 represents that it's the 5th relative position. The 7 represents that it is 7 notes away, not to be confused with the 5-note away perfect fourth. So this is the 7-note away, which is the 5th, the perfect 5th. It's also an odd number, and therefore it's in our normal chord construction, 1, 3, 5. We can just name it the 5. It's also a critical part of the major triad of the 1, 3, 5, and therefore we see it often, and that's good because I'd like to be able to find that 5th, that power chord, if you just had a 2-note chord, from anywhere, because it always works. It's ambiguous. It actually doesn't give us much flavor as the 3rd, because the 3rd is the defining character of major or minor, but it works 6 out of 7 times. You can always add it, which is great, except on the Locrian, because it's crazy. All right, so we're going to be over here. We're going to say that we're on this note, and if I go 7 notes away is too far this way, so I'm going to go behind it. Remember, if I wrap this string in a circle from fret 1 to 12, wrap it in a circle, if I go 7 steps around one side of the circle, then that means I can get to the same place by going then 12 minus 7, or 5 steps in the reverse direction. So let's go that way, because I might be able to reach it with my finger. 1, 2, 3, 4, 5 behind it. So now I'm going to say, if I'm here, 1, 2, 3, 4, 5. So from here to here, from that D, that would be a 5-note away, which would be a perfect fourth, but this way, from G to D, therefore would be a 7-note away perfect fifth. All right, let's see if we can crank this out fairly fast, because we have 3 of them to go through and another joke. I have another joke, and that was kind of a long joke, so let's try this one. We're going to go up 1 here, so let's go up 1. All right, so we're looking for a 7-note away perfect fifth. When we go above it, we have to look for the inverse distance, which is going to be 12 minus 7, which is 5, a distance of 5. And we know that this tectonic plate shifted to the right in the earthquake that happened back before time even. And so now we have to go diagonal to go to a 5 this way. So we're just going to go boom. There it is. There is the 5-note distance, because normally 5-note distance would be right up above it. But I'm going to go diagonally to find the 5-note distance instead of going 4 and then 5, because I don't want to be counting up in 4s. I want to count up the strings in 5s. So it's just going to be from here to here, boom, 5-note away. If I went from top to bottom, D to G, that would be then a 5-note away perfect fourth. Therefore, from bottom to top would be a 7-note away perfect fifth. All right, so that means if I go up 1 string, the 7-note away perfect fifth will be 1 fret back if I cross the fault line, but I wouldn't cross the fault line if I was anywhere else. Literally anywhere else, I wouldn't cross the fault line, like here to here. And that means, for example, that when I go up 1 string, the 7-note away perfect fifth will be right above it or on the same fret, unless I cross the fault line, which only happens on the G string, in which case if I go up 1 string and cross the fault line, the 7-note away perfect fifth will be 1 fret back. All right, let's go up 2 strings. 2 strings. Oh, let's go up here. So now we're going to say I'm going to go above it, looking for the 7-note away perfect fifth. Inverse distance is going to be 12 minus 7, or 5. Therefore, I'm going to go diagonal, 5, and then 10. So then I'm going to say negative 10, negative 9. Wait a sec. Negative 10, negative 10, negative 9, 8, 7, 6, 5. There we have it. So I'm looking for a 7-note away perfect fifth. Inverse distance is a 5. So there's a 5 distance of 5. Hopefully I got that right. I feel like I missed something. So I'm going to say this is going to be negative 5, negative 10, negative 10, 9, 8, 7, 6, 5. Boom, boom. So if I went from this D to the G, that would then be a 5-note away perfect fourth, and therefore from bottom to top, from the G to the D would be a 7-note away perfect fifth. So if I go up 2 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3, 4 frets forward, but I wouldn't cross the fault line if I started above the fault line, such as on this G, in which case it would be out here. So normally Normally, if I go up 2 strings, the 7-note away perfect fifth would be 1, 2, 3, 4, 5 frets back, unless I cross the fault line, which would only happen on the B string, in which case if I go up 2 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3, 4 frets back. Okay, let's go up another one and say we go up to here. So now I'm going to go above this G, looking for a 7-note away perfect fifth. So I have to take the inverse distance, which is 12 minus 7, or distance of 5. It's going to be -5, -10, 15, and then 15 minus, there's only 12 notes in the musical alphabet, so 15 minus 12 is -3, 4, 5. Boom. Let's count it out this way. So it's going to be 5, 10, 15. 15 minus 12 is -3, 4, 5. Boom. So if I went from top to bottom, that would be a 5-note away perfect fourth, bottom to top. Therefore, 7-note away perfect fifth. That means if I go up 2 strings, if I go up 3 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3 frets back. But I wouldn't cross the fault line if I went up on this G string. Let's do it over here, because then it would look like that. So the rule would be, if I go up 3 strings, then the 7-note away perfect fifth will be 2 frets back unless I cross the fault line, which would happen 2 out of 3 times that I could go up 3 strings. That would be on the bottom B and E string, in which case if I go up 3 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3 frets back. All right, let's go to the top one. Go up to the top row so we can do the body slam from the top row. Now, if I go up to the top row and I'm measuring from the second to bottom string, I might say, why don't I go to the bottom one first, and then the top one will be the same as they are the same notes. So I could say, let's go down first. It's a 7-note away perfect fifth. If I went below it, I would not need to take the inverse distance, but could rather just take 7, and I don't have to cross the fault line because there is no fault line between these 2 strings, so it'd be 5, 6, 7. There's the D here, which would match up top. But let's go above it just so we can count it out that way to prove it. If I go above it, I can't go a distance of 7, but must take the inverse distance, 12 minus 7, which is a distance of 5, and cross the fault line diagonally to get to the first -5, 10, 15, and then 15 minus 12 can bring me down to -3. -3 plus another 5 is 8. And so -8, 7, 6, 5. So there it is. We'll do it this way. So -5, -10, -15. 15 minus 12 is -3 plus another 5 is 8. 8, 7, 6, 5. Boom, boom. So that means D to G up here would be a 5-note away perfect fourth, bottom to top. Then would be 7-note away perfect fifth. That means that if I go up 4 strings, I will always cross the fault line, because I can't go 4 strings without crossing the fault line, and therefore the 7-note away perfect fifth will always be 2 frets forward. If I go below it, then we already saw it to some extent. It's a 7-note away perfect fifth. I don't need to take the inverse distance because we're going below it. I don't need to cross the fault line, so I go right below it for a distance of 5, 6, 7. That's our most common power chord shape, so that should be the most familiar. So I'm going to say this goes 5 right here, 6, 7, boom, boom. So that means if I go down 1 string, the 7-note away perfect fifth will be 2 frets forward unless I cross the fault line, which would only happen on the G string, in which case it would be stretched out over here. So if I go down 1 string, the 7-note away perfect fifth will be 2 frets forward unless I cross the fault line, which only happens on the G string, in which case if I go down 1 string and cross the fault line, I would go 3 frets forward. All right.